On the other hand, Gauss realized that if you have some amount of charge here, and then you draw a surface around it, the number of electric field line passing through the surface, let's say if this is a positive charge, is proportional to the amount of charge you put inside this closed surface area. So for closed surface area, he realized that the flux passing through the surface, the electric flux, is proportional to the charge which is enclosed by that surface. And if you try to convert this proportionality to equality, you will find that this electric flux, that would be the charge enclosed divided by a constant called permittivity of the vacuum. Epsilon is how much the vacuum permits the electric field to propagate through it. For vacuum, that's technically the smallest amount. It allows all the electromagnetic field to pass through it without much of resistance. But for other elements like water, glass, this permittivity would be a different value. There is more resistance against the electromagnetic fields passing through any other mediums than the vacuum. And so what he discovered that from one side, this flux can be related to the charge inside the closed surface. From other perspective, he realized that this flux is related to this integral. So he put them together into one equation. Said the flux, the electric flux, is the integral over a closed surface of electric field dot dA, which is equal to the charge enclosed by that surface divided by epsilon 0. And so this is referred to as Gauss law. This is one of the most fundamental laws in electromagnetism. Let's have a few examples of Gauss law. Let's say you have a charge, a positive charge Q here, and I draw a surface around it called S1. What is the flux passing through S1? Very simple. Q, which is enclosed by it, divided by epsilon 0. Now, suppose I have another charge, like plus 2Q here. I can draw a surface around this, call it S2. I can define flux passing through the surface area S2 to be 2Q divided by epsilon 0. At the same time, I can draw a surface area which is around both charge 1 and charge 2. Let's call it S3. So the flux, electric flux passing through S3 would be the sum of these two charges, 2Q plus 1Q, divided by epsilon 0, which is 3Q divided by epsilon 0. Now, of course, if the charge was negative, then you algebraically add or subtract the amount of charge. So it is possible to have a situation where you have, let's say, 5Q here and minus 5Q here, and then I can draw a surface around both of them and claim that the electric flux passing through this surface S0 would be 5Q minus 5Q divided by epsilon 0, which is 0. Which, when you think about it, it makes sense. The electric field lines are coming out around this 5 positive charges, and from the negative side, the electric field lines are coming in to the surface. And between them, of course, there is electric field lines connecting the positive to the negative. But what's matter here is the total amount of charge, which is the electric field line which goes out of the surface, call it the phi for the positive one, is positive, isn't coming out, and the charge which is going in, the flux which is going into the surface area would be negative. And they're exactly equal, and so they will give you a 0.